Namaste, good afternoon. Nisha, how are you? Okay, Karya, Anushka, Subimta, how are you?
Fine, sir.
Okay, let's wait for a minute. Then soon we'll start the class. Okay, today, class 9, we are going to start the new lesson from physics. Okay, till that time, I think we may discuss something about the past lesson, that is lesson first. Okay, let me ask questions. Can anyone say the SI unit of power? POW power. The quantity is power, and you have to say the SI unit of power.
What?
Anybody?
What?
Okay, thank you so much. Yes, yes, you're right. Class 9, thank you. What? WTT, what is the SI unit of power? Okay, we have a regular shape body. One is cube, CUBE cube. Okay, to find the volume of a cube, what formula do we use? What is the formula, okay, that we use for finding the volume of a cube?
Length into breadth into height.
Yeah, very good. Yes, and especially cube, all sides you can say L cube also, right?
L cube.
Yes, L cube or A cube. Yeah. Okay, next, that is solid body shape. Okay, that is a cylinder. What is the formula to find the volume of a cylinder?
Pi r square height.
Okay, very good. Yes, pi r square h. Okay, you can use that formula to find volume of cylinder, just like pen, pencil, or like that. Okay, do you have any idea about the SI unit of angle? Angle, though we have not discussed in the
Radian.
previous classes. Radian, very good. Yes, yes. So angle can be measured in degree. Angle is measured in, that is a grade, and the angle is measured in radian. Radian is the SI unit of angle. Okay. In optional math also we read, in class 9 also we read in optional maths, radian, grade, okay, degree. Radian is the SI unit of angle, like that. Okay, and there is another also solid angle also, and that the unit is steradian, like that. Okay, now start today's class, I think. Shall we begin class 9? Okay, let's begin with, okay, the sharing of slide. Let's be ready with copy, a book, and pen. Let me share the slide. Okay, sharing. Just wait. Okay, wait for a minute. So I'm opening my file, my documents, and it is yes. Okay. So I think you can also see so on your own screen that what I have shared. So from today and onwards, we are going to discuss, okay, about the topic force. Force itself is a huge topic that we read under, okay, physics, which is one of the branch of science. So under physics, we are reading the term force. Force is a physical quantity. In previous lessons, we read force as a derived quantity, right? It is a vector. It is a derived physical quantity. Now, let's start reading the lesson force, chapter 2 force. Okay. Uh, Before we go into the topic, class 9, that the students must know, okay, that what do you need to learn or what you must learn. Okay, that reading the chapter or reading the lessons, just like at the end of the lessons, while completing this lesson force, all the students of class 9 must be able to define some terminologies. Just like you must be able to, okay, say about inertia. Okay, inertia. So inertia is the property of a body by which it can remain in its own position. Means the body does not change its position itself. So if the body is at rest, it can remain at rest, and that such type of property is called inertia. Okay, in coming class we will discuss, okay, about this term in detail. Then you have to know about that rest and motions. Then what are the effects of force? Okay, how do we define that body at rest and body in motions? And the main topic that in lesson force, the students of class 9 are going to deal is Newton's laws of motion. Okay, you might have read these laws of motion in class 7 also, for Newton's first law of motion, Newton's second law of motions, and Newton's third law of motions. So we are going to read those laws of motions in detail with examples, and then next, you must be able to calculate some numerical problems. Just like to find the velocity of a moving body when the displacement and time are given, and to calculate the oscillations. Oscillation is the rate of change of velocity in 1 second. Okay, what is the change of velocity? Okay, that change in velocity in unit time means in 1 second is called accelerations. So if you are given initial velocity, final velocity, okay, with the covered time, then the you have formula, okay, a equal b minus u upon t. And by using that formula, we can calculate the oscillations of a body. Okay, and you must be able to do or solve such numerical problems. And finally, we have another most important part, okay, in lesson 4 is equation of motions. Okay, I hope you know about Subhat, S-U-B-A-T, that S for displacement, U for initial velocity, V for final velocity, A for acceleration, and T for time taken. So we have Subhat equations, just like V equal U plus AT, okay, that S equal UT plus half AT square, that such equations first will derive, okay, we'll read about that, and we must be able to apply those equations, okay, in numerical problems. Understand? So these are the objectives of lesson 4. What are you going to read, or what you must know? You must be capable that of these topics when you finish reading the lesson 4. Okay, let me change the slide. Last time, please. So if you have copy and pen, and if you get time, you can note down on a copy. Okay, from today we are starting the new lesson 4. This slide shows outlines of force. Outlines of force means just like micro syllabus of force. The major topic is force. The name of lesson is force, and inside that lesson, so what are we going to read? Okay, the subtopics, the micro syllabus or outlines are like introduction. Okay, first of all, when we start reading the lessons, we'll read the introduction part, in which we read a definition of force. We'll read what is force and some property of force like that. And then we'll go to another topic, that is rest and motions. We'll know the meaning of what, when is a body said to be at rest and when is a body said to be in motion. And you know, class 9, that the rest and motion are relative terms. And we'll try to elaborate, okay, that is statement. Rest and motion are relative terms by giving example. And the next outline of force is units of force. Okay, I have already told you, you already know class 9, that force is a physical quantity. Okay, so it can be expressed in standard quantity, which we call unit, and the unit of force in SI system is, you know, Newton, and CGS, that is Dian. So Newton and Dian are the units of force. Then in short, we'll discuss about the effects of force. Okay, even in the picture you can see the boy is, you know, that pushing that one wheel. So how is he able to push or bring that wheel into motion? Obviously by applying force. So he is using the stick to apply the force on the wheel so that it comes into motion, right? And next topic, class 9, is vectors and scalars. What are vectors and what are scalars? And some examples of vectors and scalars, that distance and displacement. We'll go ahead reading speed and velocity. Then we'll come to acceleration. Okay, accelerations with definition, SI unit, then formula, then some numerical problems. The main that new topic, okay, that we are going to read in class 9, from 8 and 7 are graphical representation of motion. Okay, you will read the graph that is plotted between distance and time. And when we plot the graph between distance time, definitely we'll get the speed, okay, of a body or motion of body. Then another type of graph that is between the velocity and time, that is called velocity time graph. And when we plot the graph between velocity and time, and it shows the acceleration of a body, whether the body is in uniform oscillation or retardation or zero oscillations, we can see, okay, that situations of different oscillations of a moving body by plotting the graph between velocity and time. And the next topic is their equations of motion. Okay, we'll discuss about four equation of motions. Okay, three are the main. Then we'll make four equation of motions. Then we discuss about the mass and inertia. Okay, then momentum in short. Okay, definition of momentum and formula of momentum. Then in detail, so we'll discuss with examples about the Newton's laws of motions. There are three Newton's laws of motions. Okay, Sir Isaac Newton, he propounded laws of motions, okay, for a moving body. And finally, in short, we'll about balance and unbalanced force. In this way, we'll come to the end of the lessons. Okay, so for 6 or 7 periods, okay, from today onwards, we are going to read the second lesson, force. Okay, these are outlines of force. This is the opening of lesson. Okay, now let me go to another slide. Means now we are going to start the lesson. Now listen carefully, class 9. So in the part of introductions, so which we say that the beginning of lesson 4, here we try to define the force. Okay, everybody knows that. No, literally class 9. So we can feel, okay, the evidence of force. So how in our practical life, suppose when we try to push any object or pull any object, okay, towards us, at the time we feel certain pain in our body. Okay, if you try to push a big stone or if you try to pull, okay, door towards you, your body means that is the evidence of force. Means you are applying something on that object, okay, from your body. Means for that body, okay, that you are giving an external agent. So when we apply an external agent on somebody, okay, due to that external agent, we find certain changes, certain movement, okay, certain difference or variations on that body. And what is that external agent? So which makes or tries to mix, okay, that the change in the position of body, obviously, and that external agent is force. So force is simply defined at the push or pull, which changes or try to change the position of a body. Position of a body means state of a body. There are two positions, there are two state of body, okay, in regard of that motions of force. There, one is rest, another motion. So either a body can be at rest or a body can be in motion, isn't it? These are the two positions. So if a body has to change from rest to motion or motion to rest, at the time the body must be applied with some force, with some, external agent, by pushing or pulling. So by pushing and pulling, when we bring any object, okay, into motion from rest, and that push or pull is called a force. Okay, and if the ball is moving, okay, is rolling, okay, from certain height or on the ground, that when we stop the ball, and what is there that we have applied on a moving ball, that makes the, that stop of the ball is obviously we have applied force. So either by pulling or pushing, so we apply certain agent that changes or tries to change, okay, a body from motion to rest and vice versa. Yeah, that push or pull is called force. In another word also we can say simply force is an external agent that capable of changing the state of rest or motion of particular body. I hope you have understood. It's very simple. Okay, the definition of force. So this is the answer for the question: what is force or define force? In any way, we can define force is the external agent. Okay, that changes or tends to change the, motion of a body. That is our rest of body. That means motion to rest or rest to motion. And if we talk about one very simple property of force, you know that force is the quantity which possesses both magnitude and direction. So we can say how much force is being applied on a body. We say 20 Newton force, and two directions that the force is being applied: towards west, okay, towards east, or we can say upward, downward. Just like gravity of the force is being applied on the objects, okay, towards the center of the earth, means downward. So since force possesses both magnitude and direction, it is considered as a vector quantity. Okay, you can see some examples. It's like kicking a ball, rolling a ball. So these actions can be carried, or during these actions, so what is being applied on the object? Obviously, that is force. So it's very general, that is philosophy or term, that is what is there that always makes us that move from one place to another, means there is force. So if there was no force, that means we would not be able to move from one place to another place. Okay, so we locomote, so we show motion, we show movement in our body, since that we are applying the force. So force is only there, so which can change the state of a body. Okay, now let's see. There's two states, okay, that can be defined in a particular body. The two states are two position, class 9. They are rest and motion. So to define whether a body is at rest or motion, okay, you need an object which we call reference point, which we call a framework. Suppose we all at our own room, okay, that is around us. We have our books, we have table, chairs, and for us, okay, that table, chairs, books, or all of that is objects can be a reference point. And with respect to reference point, and we can easily find whether the body is at rest or in motion. Whenever the body changes its position with respect to the reference point, with respect to the surrounding, isn't it? At the time, the body is said to be in motion. And for a long time, when we observe that the body does not change its, position or state with respect to the surrounding, in the same point, in the same place, the object is being light, that means the body is said to be in the state of rest. So when is the body said to be at rest? A body is said to be at rest when it does not change position with respect to surrounding. The surrounding means reference point. And when is a body said to be in motion? Okay, a body is said to be in motion when it changes its state with respect to surrounding or reference point. And we know, class 8, these two terms, rest and motion, are relative terms. Means, so we can define both the state, okay, that is for a same body in certain conditions. Just like you can see the examples of, okay, that moving bus, so which has passenger inside it. The passengers are inside the moving bus. The bus is moving. And when we see the passengers with respect to the bus, the passengers are supposed to be at rest. Means the passenger do not change the position with respect to the bus. But in another part, when we see the passenger with respect to the that is outer surrounding, that can be a road or trees, okay, or a cloud or sky, so you can say that the passengers are in motion. So passenger with respect to the bus are at rest, but the same passengers with respect to the outer surrounding, means trees, roads, they are in motion. Because with respect to the bus, the passengers do not change the position. Okay, for a long time, the passengers and the bus are in the same position. Whereas, okay, with respect to the outer surrounding, let's say trees, for few seconds, the passenger can be in one place, but they after a few seconds, the passenger can be in another place, like that. Just with outer surrounding, the passenger in motion. So passenger inside the moving bus, okay, when studied with respect to bus, and when studied with respect to the outer surrounding, can be in both state, rest and motion. Okay, so why we can say that explain in both state, rest and motion. So rest and motion are relative terms. Okay, these are very simple terms. So I hope you understood. After one slide, I'll again come back to you. Then if there is any questions, then you can ask. Okay. Now one slide. Let me show. This is very important. Now this is the thing that you have to know, or let's say you have to memorize. units of force. The force can be expressed either in SI system or CGS system. When we express force quantity in SI system, okay, the unit is Newton. Okay, NEWTON Newton, which is denoted by capital N, and CGS system, the unit is Dian. Okay, DYNE Dian. So SI unit is Newton and CGS unit is Dian. Okay, Dian is the CGS unit of force and Newton is the SI unit of force. Understood? Okay. So before I come back to you, okay, if there are any questions, then let me say the relation between Newton and Dian. Okay, what is the relation between Newton and Dian? It is just like the relation between kilometer and meter. Okay, it is just like the relation between kilogram and gram. Same like that. Okay, Newton and Dian are the units of same quantity. Newton and Dian are the units of force, and they must be related to each other. And you know the relation is 1 Newton is equal to 10 to the power 5 Dians. Okay, 10 to the power 5 means it is expressed in scientific notation. 10 to the power 5 in general it is 1 lakh. Okay, 1 after 50. 1 Newton is equal to 10 to the power 5 Dians, means 1 lakh Dians. Sometime if you are asked to convert that Newton into Dian, then see, okay, it is already mentioned there. You can see on your screen. So in the beginning, we can see there 1 Newton, okay, is equal to 1 Newton. Okay, here it is SI unit Newton, and you want to find that equal to 1 Newton in Dian or let's say CGS system. For that, you can see that okay, this formula we have got from Newton's second law of motion. So we'll read the derivation. Okay, F equal ma in coming days. But you know the formula to find force is F equal ma. Your m is mass, a for oscillations, and c, mass is how much? 1 kg, and acceleration is 1 meter per second square. So kg is SI, and meter per second square is also SI. And then when you convert that kg into CGS, it becomes gram. Okay, so 1000 gram. Okay, and then 1 meter per second square is second is the unit, okay, in both SI system and CGS system of time. But when you convert 1 meter into CGS, it becomes, that is centimeter, 100 centimeter, and multiplying that 1000 into 100 is 1 lakh. 1 lakh means it is 10 to the 5. It is gram centimeter per second square means it is dyne in short. Okay, please class 9 understand this. Kg into meter per second square is Newton. Okay, I repeat, kg multiplied meter per second square is Newton. Okay, gram centimeter per second square is Dian. Okay, so finally 1 Newton is equal to 10 power 5 Dian. Let me come back for a few minutes, then again I'll continue the slides. Okay. Okay, till this slides class 9, okay, we started that discussing the lesson force by objectives, okay, then syllabus, micro syllabus of force, and few terms we discuss. That means we discussed the definition of force, what is force, right? Then we discuss the two state of body, rest and motion, and finally we explain the statement rest and motion are related terms with the examples. Passenger inside the moving bus can be at both situations. Okay, they can be either at rest or in motion. When we compare with the bus, the passengers are at rest, and when we compare the passenger with outside surrounding, and they are in motion. And finally, since force is a physical quantity, it can be measured. Okay, so it has to be expressed with the unit, and the SI unit of force is Newton. Okay, and the CGS unit of force is Dian. And till these slides, we ended with the relation between Newton and Dian. Now, class 9 students, all you can say, okay, 1 Newton is equal to 1 lakh Dian, 10 to the power 5 Dian. So, till this class, okay, if anybody has any questions or any doubt, you can raise the question, please. So, you will be here with us for 1 minute, then again we will continue the slide. Any question, class 9? यहाँसम्म कसैलाई केही छ त? So everybody understands the definition of force. What is force? Okay, thank you, Subham Pathak. Yes, that means now we can again rejoin. Okay, the slide. After units of force, yes, we have 10 minutes left. Then for 10 minutes, we will discuss some okay topics. Yeah, just wait. Uh, these other slides. Okay, you can see class 9. So up to here, we are clear. And the next is effects of force. Okay, to the topic, I think we should not give more time. So what does the force do? So what effects of force can we observe? The picture also tells about that. You can see the okay some farmer or some a person okay is walking with the law okay or that is a law that is cutting the grass. You can see paddling the cycle. Simply if we that is enlist the effects of force, you can say in short that the force can change the state. Okay, that means rest or motion of a body. That is also the Newton's first law of motion. If there was no force, the body at rest could not be changed into motion, or the body in motion could not be changed into rest. Okay, to change the body from rest to motion, motion to rest, there must be a force. So force is very important. Okay, and then another is it can change the direction of motion of body. Even it can change the shape of the body. You can see the scrambled paper there. The paper that kachak kuchak bhako cha ni. So plain sheet of paper can be scrambled by applying the force, and even you can see that it can change the speed of a moving body. So you can increase the velocity or decrease the velocity. Okay, that you can speed up or you can speed down of a moving body by applying the force. Now let me go to another slide without any delay. Okay, class time. Next topic is please vectors and scalars. Uh, Very easy topic, please. Okay, do not get scared. Simply in class 9, when we read vectors and scalars in science in the lesson 4, we have to know the meaning of vectors and scalars. Okay, what kind of physical quantities are called vectors and what kind of physical quantities are called scalars. Okay, let's know the meaning. Those quantities which have both magnitude and direction, okay, are called vectors. That means to explain, no, to define, to express certain quantity, that magnitude is not only enough. Okay, that for defining such quantity we need to okay show direction also. That means whenever the physical quantities are being applied to any object, if the physical quantities come with their magnitude and direction, then such quantities are called vectors. And certain quantities are there, physical quantities, which definitely have magnitude. All the physical quantities they are measurable, means they have magnitude, they have value. We say 2 meter distance, we say 20-second time, we say 2 kilogram mass, means how many physical quantities. Okay, so far we know all those physical quantities have numerical value. Okay, they have certain values depending on the quantities, okay, amount. Then they have magnitude, they have values, but for them direction is not essential, direction is not needed. Simply they possess magnitude, they possess value, okay, they possess quantity, and such physical quantities are scalars. So having both magnitude and directions are vectors, and okay having magnitude only are called scalars. Right? We can say vector quantity or simply vector, scalar quantity or simply scalar. You can see there, okay, physical quantities they are of scalar and vector, and scalar has a magnitude only, and vector okay it has both magnitude and direction. Let me show another slides which have the examples of scalars and vectors. See please. Okay, you can see on your screen class 9 some examples are given. Okay, scalars and vectors. So if you see the side of scalar quantity, you can see okay, physical quantities like length, Okay, you have area, volume, speed, mass, density, temperature, pressure, even work, energy, power. Okay, entropy, it is energy. Okay, these all are scalar quantities. Okay, they only bear value. Okay, you can say 7,860 kilogram per meter cube, that the value of density. You can say 20 pascal, that is pressure. Okay, but another side, you can see displacement. Okay, displacement requires directions. To which direction you can? So why we always express displacement in a straight line. So whenever we, okay, express that is certain path traveled by a body in a curve, okay, in a curved line, that does not show a direction. Okay, that can be a simply a distance. But whenever we show, okay, whenever we draw a straight line showing certain direction, at the time that is the shortest distance traveled by a body called displacement. So displacement has direction. Okay, once the displacement direction means the quantity which depends on displacement is velocity, and velocity is also a vector quantity. And on velocity, what another quantity that is depend, that is acceleration. So acceleration depends on velocity, velocity depends on displacement. And since displacement is vector quantity, velocity is also vector. And since, okay, acceleration depends on velocity, so acceleration is also, okay, a vector quantity. And momentum is the product of mass and velocity. Okay, if you know the mass and velocity both of a moving body, and you can find the momentum of a body. So since momentum also depends on velocity, so it is also a vector quantity. Okay, and the force, so it is always shown in that straight direction. So to which directions it is being applied. Okay, if we talk about the gravity, it is always downward straight to the center of the earth. Okay, even the electric field, in every curve there is the straight line which is the directions. So why these are the vector quantities. So you can see the picture also. You can see here mass. Okay, mass is given there 150 kg. Okay, whenever we say the mass of a person or any object as in kg, at the time this is a scalar quantity. But while converting that into, weight, so weight of a body is given by W is equal to mg, m for mass and g for acceleration due to gravity. Okay, the product of mass and acceleration due to gravity is weight. And since weight of a body depends on small g, that is acceleration due to gravity, so weight is also a vector quantity. See the 1,500 Newton, that is the magnitude. Okay, and the direction is shown downward towards the center of the earth, so it is a vector quantity. Understood? Okay, so first, class 9, the quantity which has magnitude only is scalar. The quantity which has both magnitude and direction is vector. Okay, and length, mass, and density, time, they are scalar quantity. Whereas displacement, okay, displacement, that is okay, direction, velocity, that is always vector quantity. So entropy, it is energy. Okay, energy in that certain conditions we'll discuss later on in detail. Simply, okay, it is similar to that is okay. Yeah, yeah. Second slide means which, Jendra? Okay, next slide. Now, the differences between scalars and vectors, class 9. You can see if you're asked to write the differences between scalar vector, first we have, okay, discuss many times. Scalars have magnitude and they have magnitude and direction. And the sum of scalars is always positive. Okay, that is the distance is always positive, but the sum of vectors may be positive, negative, or zero also. So the even the moving body oscillation can be zero. Okay, oscillations of a moving can be zero. Even negative also. We say negative oscillation is retardation. We can say minus 2 meter per second square, which is negative oscillation, and oscillation is a vector quantity. Okay, and to get the operations of scalars, so if we talk about the additions, then we have very simple algebra. Okay, just like 2 plus 5 equals 7, like that. And vectors are added by the vectors algebra. So there are certain laws, certain rules by which we can calculate the, okay, uh, the problems of vectors like that. And in science, for class 9, we'll talk about that sum of vectors uh, on the basis of direction. Okay, on the basis of directions. Just wait for 2 minutes. Then I'll come back to you. See here, last night, please uh, look carefully and try to understand. The topic is, okay, sum of vectors, and then sum of vectors, okay, can be found on the basis of directions. So if we apply, okay, the vectors in the same directions, okay, at the time that we'll get the positive value, or let's say we get the sum, which is more. But if we apply the vectors, or let's say force as an example in opposite directions, we get a less value. Okay, because when we have vectors in same directions, at the time we'll get the sum, right? Additions, and addition is always more. But when we have vectors in opposite directions, we get a difference, and difference will be less. For example, okay, here is one vector. This is, okay, 10 Newton force, and another also 10 Newton force. So two different forces, though they are equal in magnitude, 10 Newton, 10 Newton, but they are different forces, and they are being applied, okay, on objects in same direction, in same direction. Okay, this is also, let's say, towards east, and this also towards east. This arrow shows the direction, and they are being applied on the same direction, means now 10 Newton, 10 Newton will get what? How much force is there? The net force is 20 Newton. Understood? Okay. It's just like you can see there, another also there. Okay. This arrow shows, and this arrow shows they are being applied in the same directions. So 10 Newton and 10 Newton. Then here also we get 20 Newton. Only the difference is that opposite to, or let's say different to the first, direction. Here in number one, let's say direction is towards east, but here towards west and towards. But for this direction same. Okay, so same direction and same directions, we always get the net force as sum. Okay, net vector as sum, like that. But if you see here, now 10 Newton is applied towards east. Okay, 10 Newton on same body is applied just to the opposite direction. They say towards west. Okay, these two forces are being applied on the same body, but one